Welcome to a lesson with Dr. Powell. Let's take a look at how we can use fiberbox diagrams in determining the existence of a function between two different codomains that come via maps from the same domain. Does there exist function here that completes this is a commutative diagram, meaning that we can go this way or that way and arrive at the same spot. We're going to further say that these functions f and g are surjections, meaning that that the fiberbox diagram is just a partition of D for this function and for this function. We've just basically partitioned our domain. Every single chunk here in the domain exactly represents one of the elements in the codomain, because there's going to be no extra elements in the codomain because it's surjective. Okay, so that means that if we look at the function g here, and let's suppose that this box represents D, the domain D. The function G partitions D up perfectly into different pieces. Suppose it does it into maybe like 2 pieces. So that's what the function G does. Now, what does the function F do? F is also going to divide D into different pieces. Now, in order for this to work right, what we need to be able to actually have a function that goes from this codomain, C1, codomain 1 to codomain 2, right? The codomain of G, codomain of F. There needs to be a function between there. How do we represent the pieces of this first codomain? We represent them precisely as, because this is a surjection, as chunks of D. Exactly. So every one of these guys in here is actually represented by a chunk in D. And we need a function that goes from chunks in D that exactly represent elements in C1 to the chunks of G, which exactly represent the elements of C2. So so basically we need a function that goes from these chunks to those chunks. And the basic idea of how to go from chunk to chunk is if F, say the chunks of F, let's suppose the chunks of F were something like this. So suppose this is a chunk of F, okay? So it represents an element C1. So maybe these are the elements of C1. Maybe I'll label them as 1, 2, 3, 4, and 5. Those are the elements of C1. The elements of C2 are these two guys. Let's suppose that this one is A and this one is B. So guess what the rule is? 1 goes to A and 2 goes to A. 3 goes to B, 4 goes to B, 5 goes to B. There's our function. So we just came up with a function that's called H. A table for H would be as follows. For input to output. Okay, so input to output, we have 1 and 2 both go to A. 3, 4, and 5 all go to B. So we've just come up with an induced function H, and it depends on this idea. Basically, what we need that the function F, the fiber partition of it, needs to be an exact refinement of the fiber partition that comes from this function G. And then we can get this induced function H. Let's look at, and in the next video, we'll look at an example of that. Thanks for watching.